Hi everybody, welcome back. We're going to be on page 8 of chapter 4. We're doing section 4.3, solving quadratic equations by completing the square. So what you're going to do is you're going to want to recall what a perfect square trinomial looks like. Remember, it's a plus b all squared. You square the a value to give you the first term, you square the b value to give you the third term, and you multiply the two terms together and double it to give you the middle term, as we've done in the past. So let's take a look at what we've done so far. So here, what we're going to do is we're going to, and again, this is a little bit of review. So half of 14 is 7. 7 squared is 49. Half of negative, let's look at B. Half of negative 20 is negative 10. Negative 10 squared is 100. Perfect. Let's convert each of the following into vertex form, which we did in the past. So remember the first one here, when we have the, we'll finish these, sorry, we'll factor these like I mentioned, I do apologize. So factor that, we'd have x plus 7, x plus 7 equals x plus 7 all squared, right? And we'll do the b part over here, and we'll do the same thing. I'm going to cheat here, make it minus 10, and minus 10, and obviously minus 10 squared, as you guys are aware. Okay, now we're going to convert the following functions into vertex form. So you can remember what we did in chapter 3. Remember, I would take the 32, the constant, I would bring it to the far right. I would put in brackets my what I'm going to do to complete my square to get the perfect square trinomial. Half of 18 is 9. 9 squared, as you guys do recall, is 81. Okay, but remember, to keep this, we'd have to subtract 81 as well, right? Because we can't just add 81 out of nowhere. So if we subtract 81, we're actually adding 0, the 0 principle. And to simplify this into vertex form, all right, I'll recopy this line. Remember, this here changes into x plus 9 all squared. So I'm going to steal this from here. We get the x plus 9 all squared. And then the minus 81 plus 32 we add together, and we get minus 49. Okay, again, I'm doing this quickly because we did this in the chapter 3. This is not new material. Okay, now in example B, we'll do the same thing. Remember, rewrite the question, leave a little space to complete the square, leave a little space to subtract what we've added in order to, or vice versa, right? Depending if there was a negative out front, of course, to make it 0. So half of negative 8 is negative 4. Negative 4 squared is plus 16. Do you remember? We can't just add 16 out of nowhere, so we have to subtract 16 to keep the equality, right? So we essentially add nothing like we talked about. We've added 0, 0 principle. All right, so I'm going to recopy this, and then we're going to change it into the form that we need, right? So remember, all of this will change into x minus 4 all squared. So I'm going to steal this for a minute up top here. This will all change into x minus 4 all squared, and then we take the negative 16 and subtract 4, and we get negative 20. Perfect. And it's in vertex form. So we're going to do a little bit different. We're going to put a little change on it here. Nothing too crazy though. Okay. All right, so we're going to do this a little differently. You'll notice I wrote in what we have here. So what I've done is I've taken the 23 and I've subtracted it from both sides. Okay, leaving this base. So this gap here, what we're going to do, this is where we're going to complete the square. So we're going to add 25 to this side. Remember, normally we'd subtract 25 here, but instead of subtracting 25 from the left-hand side, we're going to do what we did when we used to balance our equations, right? To keep them balanced on either side, we'll just add 25 to both sides. Again, which essentially, it's not changing the equality of the question, right? It's still going to be okay. All right. Now this part here, this will change into x minus 5 squared, as we did when we were completing square change in vertex form, and the negative 23 plus 25 becomes 2. So now we have this interesting question now. I know normally before we would take this and we use the quadratic formula to solve it, but now it asks us to solve the equation by completing the square. So we're solving for x in a different method. Which is neat about here is now what we can do is we can just take the square root of both sides. Because if we take the square root of both sides, then we'll be left with x minus 5. So what I'm going to do next time is I'm going to take the square root of both sides, and in doing so, that's what we end up with. And then once we do that, we have, oh, sorry, we have x minus 5, because the square root of anything squared is itself. And then we'll leave this as square root 2 for a minute here. I'm going to show you why I do that in a second. All right. Okay. Now we'll set both sides equal to x. So, or the left-hand side equal to x. So we'll add 5 to both sides. Right. So we add 5 to both sides, which eliminates that, and we add 5 here. And I'm going to show you why I'm going to change the order in which I add. Not that it's going to change the value at all. So I'm just going to rewrite this as x equals 5 plus the square root of x. And the reason I'm going to do that is because when we take the square root of 2, that can be 2 possible values. As you're aware, a quadratic will end up giving you 2 values, of course. So I'll show you what this looks like. So now I'm going to split it into 2x values. So now I have x plus 1 is equal to 5 plus square root of 2, and x squared is equal to 5 minus the square root of 2. Because if you take the square root of 2, essentially it's going to be plus or minus the square root of 2, right? So maybe a better idea is when I take the square root, maybe I should have put a plus or minus sign in here. If that may help. It doesn't matter when you put it in, really, at the end of the day. But I'll put that in there if you wish, right? Okay. And then that's where I split it, if that helps. Okay? Right, because when you take the square root of 2, it's actually plus or minus, right? So that may help you with your understanding of why the subtraction's here. Because you take the square root, it could be positive or negative. Okay? And there's our answers, and we just take the square root. Again, it's a decimal. This is an irrational number, so it does go on forever, but I just rounded to thousandths place. Okay? I'm going to bring up Desmos just to show you that you will get these two. So plug this in. So you know your original equation, x squared minus 10x plus 23. Remember I said in class you can't get these wrong, so what we'll do is bring up Desmos. What we'll do is we'll put our program, put it in, but instead of putting 0 in, we put y equals, like you know how to do it in a graphic calculator, right? So basically it just means when y is equal to 0, what is the x value? And that's basically the x-intercepts, right? As you guys are aware, and that's what we've done in the past. So you'll notice your two answers are the same. I put the original equation in, setting it equal to what, putting it in as a function y equals instead of the equation 0 equals, and there you are. And it shows you that it's just a quick verification that they're correct, right? Pretty cool little approach to show that's right. Do the same thing here with the next question. All right. So remember, when we're solving an equation by completing a square, on your left-hand side, all you want is your x squared term and your x, right? Your bx term. So your ax squared term, your bx. They used a here. Maybe not a good idea because don't get confused with the a for the vertical stretch. So I take the 7. It's positive 7 on the left-hand side. So I subtract from both sides to get negative 7. I'm going to complete the square. Half of negative 6 is negative 3. Negative 3 squared is plus, right, plus 9. So we're going to add 9 to both sides. That's a coincidence that we get 2 again on this side. Not that it's a big deal. Oh, forget my a. Okay. So the a's are just x's here, right? And, so I'm going to steal this because it's going to be very similar. All right. Oh, sorry. So it's going to be a and half of negative 6 is negative 3, right? So it's negative 3 squared, and you get this part here. And everything else is the exact same. So I'm gonna steal these lines here, guys, and just that's an a, that's a 3, right? Square root of both sides again. Copy. A minus 3, because the square root of anything squared, doesn't matter what's in that brackets, plus or minus there. And then we get a equal to, then we add 3 to both sides. And then after that we can, you can rearrange it to the other way, put 3 up front, it's up to you. Right, so put 3 plus or minus. That's kind of why we put the 3 in front, because it's plus or minus the square root. And then you do the same thing you did down here, but I'll just do what A equals to. So so I'm going to skip a little bit of work here. I'll just say that A1, A2, and this would be 3 plus 1.4, so it would be 3, so it would be 4.14, and that would be 3 minus, so it would be 1.59. Okay? So these are your answers here. Just another example, and you can check those as well if you want to go to your Desmos program for a minute. Put in your question. Again, you can literally put it as A, it doesn't matter, A squared minus 6A plus 7, and you can click on, and you'll have the same two solutions, right? You don't set it equal to 0. I mean, you could, and then, but you don't get anything, right? So that's why we want to set it equal to Y. Because again, our graphing calculator shows that as well, and then this is just a verification showing that they're equal. So when Y is equal to 0, right, because here's your Y values, right, we just make a function in our graphing calculator. Okay. All right, so that's it for page 8. We'll do example 2. It's going to take a few steps. So I'll create a new video for example 2, and that'll be it for section 4 decimal 3. So we'll see you guys again soon.